All right, so today we're going to be talking about addition, subtraction, multiplication, and division properties. Um, Similar to what we were doing the other day when we were solving our equations using two steps, one steps, and so forth. Uh, it's kind of like examples right here. So here we have x minus 7 equals 16, right? So most of you guys, hopefully, you would add 7 to both sides. Notice how I'm adding the 7 to both sides on the equation, and then I would get x equals 23, right? So forth and so on. This is the situations that I would do. Just like here, in order to get rid of this 12 right here, we would have to subtract to both sides. And in this situation for C, we would have to divide both sides by 4 in order to get our variable by itself. And then on D, we would have to multiply both sides. I'm assuming that's 8. It could be negative 8. Okay. But notice how on this situation, I'm doing it to both sides. So, you guys were doing this yesterday, probably without even thinking about it when you were solving for your equations. Well, in geometry, we call these specific algebraic properties. We like to use these algebraic properties in things we like to call proofs, right? This is just an introduction. We'll talk more about that, but sometimes we focus on what we call two column proofs. And a two column proofs, you'll have something like this where you make your statements, which is pretty much what you guys were doing yesterday when you were solving your equation, right? You were subtracting, adding, dividing, multiplying, so forth and so on. And on the right side, this is the new stuff. This is your reasons. So you're going to state your reasons that you've been doing your statements. So you're going to explain your statements and what you just did. So, like I said, it's pretty much exactly what you've been doing. Just now you want to write these reasons for your statements. Okay. So these are some properties we already know are algebraic properties. Um, in logical arguments or in proofs, as we say. Okay, so your addition property is when you're adding the same thing to both sides. So, kind of like we did on example A, where we added 7 to both sides, that's called the addition property, right? So, those are some specific examples where we add the same thing to both sides. We're adding the 7 to both sides. So, if I had this equation, if A equals B, then A plus C equals B plus C, because notice that A and B are equal to each other. Okay. And so I'm adding the C onto both sides of the equation. Notice I'm adding the exact same thing. So that's called the addition property. Okay. And then, of course, the subtraction property, very similar to that one. You're subtracting the same value to both sides. In this case, I'm subtracting C to both sides after stating that A is equal to B. Okay. Now, these are in some conditional statements, and we'll talk a little bit more about that tomorrow or Friday. But this is very important. If A is equal to B, then A times C equals B times C. Notice one of the biggest things that you want to see is that you're doing the same thing on both sides, right? After stating that the equations are equal to each other. And then, of course, this one right here, and this is division property. We got to be careful. C cannot be 0. Now, that's okay. It's all fine and dandy because you can't divide by 0. So if A is equal to B, then A divided by C is equal to B divided by C. And here's some mathematical examples here from what you did that state these specific properties. But you'll notice that when we do these proofs down here, it'll be a little bit easier. Okay. And then, of course, you have your substitution property. Now, guys, this is where a lot of people get a little tricky. Substitution property can kind of get a little tricky. It says if A is equal to B, then A can be substituted for B in any equation or expression. So I have to start off with this statement. And we'll talk more about this substitution piece here when we start getting into more equations. So we always start 99% of the time with our proofs. Remember, statements, reasons, right? So my statements is going to be my actual math, and my reasons is going to be the statement for the math. Well, we got to start somewhere, right? We don't just have numbers coming out of air. We start somewhere. So we always start with whatever statement we had to begin with. And the reason we start with that statement is because that's what we were given. So you're going to see on a majority of these properties, these proofs, that we start off with given. right? That's our very first stuff because these numbers don't just come out of nowhere. So again, 99.99% of the time, that first reason is given because that's what you start off with. So, thinking about this example from yesterday, right? A lot of you should have gotten this already from your assignment. And most of you probably got x equals 9, right? Well, how did you get x equals 9? Well, what did you do to both sides? You add 8 to both sides. So, what you're doing in this situation to give you your next statement is x equals 9. Now, notice right here what I did in this step to get to the following step, right? I add 8 to both sides. So from get to get from statement 1 to statement number 2, I'm going to use what we call the addition property of equality. And that's really what it's called. But let's go ahead and abbreviate here. The addition property of equality, right? Notice I'm adding to 8 on both sides. So some of these things are very simple, one step pieces, right? These are why we call them one step equations because you're only doing one thing. Okay, in this process, you should have got x equals negative 23, I believe. Okay, and the reason for that is when I move this 15, right, I can't just move it by itself. I have to do something. So that's why I subtract this 15, right? And again, notice how I'm subtracting 15 to both sides. So again, for this case, this would be the subtraction property of equality. And we're just going to go ahead and abbreviate a little bit. Okay, so those are our two-step equations. Pretty simple process. Just like number three, well, number three, we start with given, and then we would divide, right? Number four, right? So we get our division property of equality, right? Notice how you're basically just saying what you did, right? Uh, you guys already know this step, so you're just stating it, right? So we would get x equals negative 12, right? Okay, or x equals 18, right? Now, how did I get 18? Getting rid of this negative 3, which is the opposite of division, would be multiplication, right? And a negative times a negative is a positive. That's how I get x equals positive 18. And that would be by our multiplication property of equality. Okay, so let's do stuff that's a little two-stepper. So notice that, and these ones, the first one is blank. So the very first one you want to do is given, right? Because you have to start off with your given statement, right? Numbers don't just appear out of nowhere. Okay, now what we want to do is we want to isolate for this x. So that's whatever's in front of the x, that's the last thing we're going to do. So the first thing I'm going to do is get rid of the 11. And how do I get rid of the 11? Right? I'm adding 11 on the left side. So in order to get rid of it, I have to use what we call the inverse operation. The inverse of adding 11 is to subtract 11. Right? And notice how I'm subtracting it to both sides. So once I subtract it to both sides, I'm going to get something like this. 8x equals, what is that, 48? Negative 48, my apologies. Okay. And that's my second statement. So here's my first statement. Here's my second statement. Now, how did I go from my first statement to my second statement? I use my subtraction property of equality. Okay. And then I'm still not solving for x. I got to get there, right? So my next statement is going to be after I use the next property to get from my x. And in this case, I would be dividing by 8. So my last and final statement is going to be x equals negative 6. So how did I get from statement 2 to statement 3? I divided. So I'm going to use my division property. And that is how we get our statements, right? So here's my statements, here's my reasons, and this is what a two-column proof kind of looks like. And this is algebraic proof, so it's pretty simple, not super complex. Okay. Um, you can follow the same procedure using number 5. Of course, we start off with given, right? So on number 5, we start off with given. Now, what we want to do in this process, right, is you have your x's here, right? And so our next statement is going to be a little different. It's going to be 6x plus 13 equals 1. And that's what we call combining like terms. So that's what I use CLT, combine like terms. Okay, always look, if you need to, draw your line on your equation right there so you know if they're on the same side, you need to combine. And then from here, it's a two-step equation. Okay. Um, I would subtract 13 to both sides. So I know I'm going to use my subtraction property of equality. Okay. And then my next statement. So this would be statement one. This would be statement two. And our third statement after the subtraction would be 6x equals negative 12. And then my fourth and final statement, which is going to be the reason after this, I'm going to get x equals negative 2. Now, how did I get negative 2? Hopefully, you know, I use division, right? My division property because I would divide both sides by 6. Okay. And last but not least, number 6. A little bit complex, but you can hopefully see it by doing your algebra. Obviously, again, notice I'm going to start off with given. Okay. Now, in this situation, it's going to be a little bit different from what we did last time because notice we have x's on both sides. Okay, so we want to get our x's over to. Now, there's multiple ways to solve for this, but what I'm going to do is I'm going to move it so that my x's are positive. So I'm going to move this 3x over to the other side of the equation. And since it's a minus 3x, remember, I got to do the inverse of it. I'm going to add 3x. So notice what I'm doing to both sides of the equation, right? I'm adding. So for my second my second reason, it's going to be the addition property of equality. Well, if this is my first statement, my second statement is based on that reason of addition, which should be 7x plus 9 equals 16. Okay. Now it's a little bit more simple. You got a two-step equation. Okay. And again, we're going to isolate for the x. So we're going to get rid of the 9. Only way to get rid of the 9 is to subtract. Okay. So our third statement should be something like this. 7x equals 7, right? If you subtract 9 from both sides, right? That's what we're doing, subtraction. We get 7x equals 7. And then my last and final statement, number 4, is x equals 1. Be careful here. We're going to divide. Okay. So, and that's how this process works.